Okay. All right. So let's. Why don't we get started? We'll have a kind of a warm up problem. Make sure we understand the concepts that we covered in the last class. So we'll say in the population, let's say somehow it is known that 32% of households own a dog. I'm making this up, okay? But we're going to pretend like this is fact for the sake of this problem. Okay? We select a random sample of 50 households. And we shall say, we're going to ask a question, what is the probability the random sample ends up with 40% or more owning a dog? Okay, I'm going to put up some answer choices here and go ahead and try this out. I'm going to have 0.066, 0.08. I need my calculator to make up these numbers. I get 0.021, 0.1587, and 2.1121. Let me just verify my numbers here. Oh, 1131. All right, so go ahead and do your answer choices. And of course, this is, I guess I should say, what is the approximate probability here? Okay, so go ahead and try this out. You can work with your neighbors if you'd like, or you don't have to. No one's going to force you to make friends. do I have? Are we good? No, I know a lot of you guys are still working. Are we able to at least work? More or less. All right, we'll just say maybe another 20 seconds here. Anybody got plans for the weekend? Study? Write papers? No, I don't know. Yeah, I don't know. Oh yeah, it is Mother's Day. Yes, yes, that's right. No, I knew that. I knew that. Huh? No, no, no. My wife's friend is getting married on Mother's Day, and it's like you know, we're going to the wedding, so. Okay, all right. I'm gonna hit stop here. So if you haven't clicked your button, click. Okay, here we go. All right, and so the value, the idea here is that in the population, 32% own a dog. So whenever we take a random sample, we're expecting something around 32% in our sample to end up owning a dog. But of course, because of random sampling, maybe we'll get more, maybe we'll get less. And so the question is, you know, what's the probability I end up getting 40% or more? So I want to know, what is this area over here? Okay. So from what we covered last class, we know that p hat follows a normal distribution with a mean of 0.32. So this is normal with a mean 0.32, and our standard deviation is going to be 0.32 times 1 minus 0.32 over the square root. Okay, and this turns out to be 0.066 when you do this mathematical operation here. Okay, and so we want to turn 0.40 into a z-score. So our z-score is 0.40 minus 0.32 divided by, what is it? Oh, 0.066. I don't know why I couldn't see that for a second. Okay, so 0.4 minus 0.32, 0.08 divided by 0.066. That's 1.21. I get a z-score of 1.21. Okay, So I want the area to the right. Okay, so the area to the left, if we look this up in our z table, I think we get 0.8869. Area to the left of z equaled 1.21. So the area to the right is 1 minus that, or conversely, I could have looked up negative 1.21. It's going to be 0.1131. And that is our answer. So looks like 94% of you got that correct. So, or 90% of you got that correct. So good job. And that's what we have. Okay. Questions? Again, this is an approximation because we're approximating the sampling distribution with the normal distribution here. Okay, so all of this sampling distribution stuff depends on what we call the central limit theorem. So the central limit theorem is a mathematical principle that allows us, so I'm going to kind of skip when I say mathematical principle, I'm going to skip the proof or anything like that. I'm just going to say, hey, this works, okay? This is the mathematical principle that allows us to use the normal distribution to approximate the sampling distribution. Okay? And again, the sampling distribution is the distribution of those p hats, or in the future it'll be the distribution of x bars. The actual distribution of p hat and x bars is ever so slightly different, but central limit theorem says, hey, we can approximate this thing with the normal distribution. Okay. But there are a few conditions or assumptions that we make in order to use the central limit theorem. Okay, so there are a few conditions. And assumptions. In order to use the CLT, okay, or in other words, to use the normal distribution as an approximation. I mean, so the central limit theorem is very useful to us because it takes this complicated thing, the sampling distribution, and it turns it into something that less complicated, the normal distribution. Okay, and so even though it's not 100% accurate, it's a pretty good approximation. It's like good enough for almost all of our stuff, and the rest of the class depends on this approximation because we're going to say, okay, now that we know that this approximation works, we can start doing all of these other things. Okay, so it's a very good approximation, and so it's very useful. But we do make a few assumptions, or a few conditions are necessary. Okay, and so I'm going to list these off. Okay, so conditions for using CLT. Okay, the first one we're going to call the random / independent condition. Okay, and basically, if we want to use the central limit theorem or anything like that, our sample needs to be a random sample, okay? So our sample needs to be a random sample. So the data that we have must be a random sample, and the individuals must be independent of each other. Okay, so if this doesn't work, then it's not gonna work out. Okay. All right. Here, the next one we're going to call the large sample condition. This means our sample must be large enough. Okay, and so when you're dealing with a categorical variable, the way we check this is just is a little different for numeric variables. So for a categorical variable, okay, there's two ways to check it. One is n times p has to be bigger than or equal to 10, and n times 1 minus p must also be bigger than or equal to 10. Okay, or if you don't have n and p, then in the data, you must have at least 10 successes and at least 10 failures. You guys can read that. So your sample must be big enough so that you get at least 10 successes and at least 10 failures, or that n times p is bigger than or equal to 10, which is basically you're expecting at least 10 successes, and n times 1 minus p is bigger than or equal to 10, so you're at least expecting at least 10 failures. Okay? If you don't have that, then your sample is not large enough to use the central limit theorem. There's still going to be a sampling distribution and all of that. It's just we're not going to be able to answer the questions because it doesn't follow the normal distribution. Okay, and then the last condition, this is called the big population condition. And I don't know, maybe the book puts these in a different order, I'm not sure. Okay, huh? The big population condition, basically, your population needs to be at least 10 times bigger than your sample size. Or conversely, do not sample over 10% of the population. Okay. So these are kind of the three conditions that we need to check if we want to use the central limit theorem, or if we want to approximate our sampling distributions with the normal distribution, which in this class is going to be all the time because we won't know how to deal with things that don't follow the normal distribution here. Okay? All right, so I'm going to give you a scenario, and you tell me if all of the conditions are met or if any of these conditions are violated. Okay, so decide in the following scenario if any condition is violated, we're using CLT is violated. Okay, so your answer choices will be random and independent condition violated. B will be large sample condition violated, or big population condition violated, or all conditions met. Okay, so we'll say UCLA administrators decide to conduct a survey of its undergraduate body, undergraduate students, of which, you know, there's approximately 28,000. Okay? They send surveys to a random selection of 2,500 undergrad students. Okay. They get responses from 1,200 students. Okay. Of the respondents, 70% said they are politically liberal. Okay, all right, so basically, are any conditions violated to use this data? CLT, central limit theorem. So I'm going to go ahead and hit question CLT for this data. Okay, so you can discuss with your neighbors what you guys think. How are we doing? Good? What's that? You have your answer? No? Okay, we'll just say, I don't know, a few more seconds here to get your clicks in. You got to make a choice. Okay, I'm going to hit stop here. So here we go. All right, let's go through this and talk about this. Okay. So if we look at the population, we've got 28,000 students. Our sample, we sent surveys to 2,500. So our population is 10 times bigger than the students that were surveyed. Okay. We look at the data that we have. We got respondents from 1,200 students, and 70% said they were politically liberal. So if we do 70% of 1,200, that's over 10. And 1 minus 70%, or 30% out of 1,200 is also bigger than 10. So that is fine. The question is our data random? And the answer is no, okay? Even though they've selected random students, okay, they only get responses. There's only responses from 1,200 students. So this is, the respondents are not random. Okay, people who respond to surveys, they are not a random population, okay? Generally, people who respond to surveys are ones who care about the stuff being asked about, okay? Or a lot of people, you get a survey, you just throw it away or you ignore it, okay? And so people who respond to a survey are not random. So the random condition is violated in this situation, okay? So survey respondents are not random. Okay. And so you have what we call the voluntary response bias. And so, random independent condition is violated. All right, and I know a lot of you guys felt like all of the conditions were met, but only those who answered A got it correct, okay? So. All right. What's that? It's okay. We'll get through this. Don't. All right, I'll give you another scenario here. You can decide if anything is violated or not, okay? So we'll say a company has, I don't know, 6,052 employees. Okay, HR surveys 500 randomly selected employees. Okay, I'll respond. It's a mandatory survey. Okay. And so of those surveyed, HR finds that 98.8% of them own a television. Okay. Are any conditions violated to use the central limit theorem with this data? Okay, so the survey is open. Okay. So those of you who haven't responded, get your clicks in. Clickety click, click, click. Okay, and I'm going to hit stop. Okay, let's take a look. Okay, so in this case, we have a randomly selected group of people, and everyone responds, so we don't have to worry about a non-response or a voluntary response bias messing up our survey. And you know, if you're at a company, you can mandate people respond to surveys and stuff, and that's fine. Okay. There will be a survey released on CCLE. Like a colleague of mine is conducting some kind of survey, so I'll put that up on CCLE. It'll be worth an extra credit point. Okay. Ooh. All right. So this. So you can help out a colleague. I think they're surveying opinions about diversity. Okay. So anyway, 98.8% respond. They surveyed 500. Okay, so 500 times 10 is 5,000. So that's smaller than our population. So our population is big enough. So that's okay. Okay, and we're met. When we check the large sample condition, we have to do 500 times 0.988. Okay, and we get something like I think 494, if I did my math correctly. Yeah, 494. And then if we do 500 times 1 minus p, or technically this is a p hat. P hat is 0.988. If we do 1 minus 0.988, we only get 6, okay? Both of these have to be bigger than 10. This is not bigger than 10, okay? So, so the large sample condition is violated, okay? This is not bigger than 10. Okay, so the answer there is B. Okay, so good job, 82% of you. Good, or not so much? Okay. All right, so let me just cover just a kind of few, I don't know, terms and big picture things. This should be review. This up to here is about as far as we're going to cover in Chapter 7 for the midterm. Okay, so you have a midterm exam 1 week from today, and it will cover up through this stuff here. Okay, I'm going to finish up Chapter 7 next week, Monday and Wednesday and stuff like that. But that stuff will not be on the midterm, so you're responsible for knowing up to today's stuff. Okay, so just a few key terms, and this is should be review. So the population is everyone, and we mean everyone, relevant to the research question. Okay, and again, this is too big to be observed directly. Okay, the sample will be the selection from the population that we do observe. Populations have parameters. Parameters are quantities or are values that are properties of the population. So for our categorical variables, our example is P is the parameter, and this could be the proportion, if we're talking about politics or something, proportion of the population that support whatever candidate, okay? If you want to vote in the primary election, I think today's the deadline to register. So, if that matters to you, keep that in mind. Being in California, we generally don't make a huge difference in primary elections, but because the decision is often decided well in advance of us. But your voice can still be heard. As far as statistics goes, these are the corresponding values in the sample. Okay, so in our case, the example would be p hat. So p hat is the proportion in our sample. This is the proportion in our sample. that support candidate, whoever, okay? All right, I left off a few letters over here. It's the proportion of the population. I guess portion of the population is not wrong. Proportion of the sample that support whatever candidate you get there. Okay. So these are terms, I think we're familiar with these. So just keep in mind parameters versus statistics, and then just a few couple ideas is that sample statistics will vary from sample to sample. This is expected because of random sampling. Okay, but the distribution of our sampling statistic, the distribution can be modeled with our sampling distribution. Distribution can be modeled with a sampling distribution. Okay, and the central limit theorem basically says that sampling distribution can be approximated with a normal distribution as long as those conditions are met. Okay. Normal distribution as long as conditions are met. Okay, and then this last point, it's a little counterintuitive, but the accuracy, and we'll talk about this in a future lecture, the accuracy of the sample statistic depends only on the sample size. On the actual sample size. Okay, it does not depend on the population size or the ratio between the sample to the population. Okay, and so that covers the first half of chapter 7, of which you will be responsible to know for the midterm exam. Have a great weekend, you guys. We'll see you guys back on Monday.